Okay, everyone. Welcome to EE360, the discussion portion of your EE360 Signals and Systems class. So that was a bit of introduction music, by the way. So welcome to EE360. In this portion of the discussion, we'll be going over MATLAB, and we'll be showing you how to effectively use it and get you started with how to use it effectively in your upper level classes and do signals and systems and stuff. So to recap, so last week we already did an online live discussion via Zoom, and that went successfully well. And we went over a bunch of really cool practical tips to finish your assignments. But for now, we're just gonna go over what we said on Friday and probably a little more in depth, and maybe keep some stuff like, well, if you didn't watch the online lecture, you'll have to watch it, and maybe you'll get some tricks. So before we start, MATLAB right here stands for Matrix Laboratory. So MATLAB is a matrix-oriented application, so we're going to be dealing with cells and arrays and all that good stuff. So as you'll notice, we have MATLAB. Oh, oops. I don't want to delete that. So I just installed this, by the way. So you'll be on the same boat. So we're both looking at this the same way as if it were fresh. So for those who have MATLAB, this is probably what you'll see. For those who don't have access to MATLAB, there is Octave, which is the free version of MATLAB, but there's probably some internal software stuff you'll have to do. But for the majority of the entire class and this semester, we'll be using MATLAB to finish your assignments. So I definitely recommend MATLAB. It's a huge investment. I use it all the time in research. I use it in every all my classes, and it's always been there for me. So you'll probably notice this window that we have here, and this right here is our command window. So this is where you can do whatever you want, such as maybe declare a variable, and you're like, hey, how'd you do that? And I want to tell you this right now. For those who have never used MATLAB, it's not like a crazy programming language. First off, just at the beginning, let's just treat it as a big calculator. So if you don't believe me, let's go to our old friend 1 + 1. There you go. You want to spice that up? Let's go to 2 × 2. Ooh, you see, pretty. And what about this? Square root of 9. Guess what that is? Oh yeah. So does calculations, and it can be used if you want to. You can have MATLAB on the go. There's also MATLAB mobile if you want to look at that too. But for now, MATLAB, just treat it as a calculator, not a crazy programming language. But by the end of the semester, you'll wish it was like a legitimate programming language, like C++ and all those other languages. But all right, so now that that's over, let's create a new script. There's two ways. You can either create a new script here, or if you have OCD, you can click here, new script. There you go. And this is probably what you'll see. So what I like to do is I generally like to double comment. Let's call it the EE360D first video. So for this first video, we're just going to cover super basics and probably go a little more in depth into the assignment. It's not going to be that long, but we'll probably go over some basics things. There is also a video provided by Dr. Stubrud, but I'll be going over my version, so you can have 2 point of views of how to approach the problem. So right here I have our little assignment. So I'll be doing some quick arrays. So let's just pull that out right here. So the first thing you'll notice is you'll come through generating simple signals, and it's easy to create some signals. So let's copy paste this right here, and suppose you wanted to instantiate a matrix. The way you can do it is you can call 1 2 3 4 5 6 7 8 9 with these little semicolons, and if we press run section, this will run a little thing, and now you can have a matrix. But this is right here in the command window. But where's my data? Here it is, the workspace, and you can see it's a matrix. Oh, look at that. It's like Excel, but bigger. So that's where all your variables are going to be. And if we go through the assignment, look, that's our proof. And if you want to copy this one too. By the way, I edited this assignment so that it's easy to copy paste stuff. There's two ways of running stuff too. So you can either press this or that. But let's press this one, run. And let's try to save it to a place. Let's go to documents. Doesn't matter where you go. EE360D. There we go. And let's call this videos or something like that. There we go. Cool. MATLAB stuff. And let's call this one EE360 first video. And there you go. So keep in mind your directories. You gotta make sure you know where you're saving some stuff, but always just remember where you go, because if you don't know where it's saved, then you're gonna have a hard time finding where that file is again. Once you do that, change your folder. It's nice to change your folder. Now you have a clean current folder, your current working space. So, oh, by the way, it ran. If you don't believe me, let's do it again. You can't really necessarily see it because these are outputting. To suppress that output, we just put a semicolon right there and press run. Now it's running. So now that we've generated matrices, which is the point of this part of the assignment. So we have a matrix. Let's say we have this matrix right here. So let's run section and let's view that data. We have this nice little row with 4 columns, and suppose you wanted to flip it. So let's call it a X flip. So you can do it 2 ways. You can either manually flip it, but we'll introduce to you our little command right here. Let's zoom in. We have this little period followed by this apostrophe. That's what it's called. So let's do this. So what I'm doing right now is we're calling this function. This function has our data stored, and we're gonna flip it. This command just says we're gonna flip it. And you're probably asking, why do we have the period? Why can't we just do this? So they're both different. So this one right here is to flip all the data, raw data. So whatever you see here, you flip it. And suppose you had imaginary numbers and you wanted a complex conjugate. Well, this right here is a complex conjugate apostrophe. So for all purpose sake in the whole semester, I would recommend using this. Unless you really know what you're doing, then I would go for the apostrophe, use that. But let's show you an example right here. So I'll press run section, or you can press Control Enter, whatever makes you happy. So, oh, look at that. Now we have 1 column of 4 rows, so pretty good to know. So now that we have that, let's try not to make the video too long. So we have this actually. Let's do X flip complex. By the way, you can call your variables anything you want, as long as you keep your left hand variables something that you can store to, and your right hand variables as well, your play field, whatever you want to put into the left hand side. So we have our X flip complex. Let's just copy this X. So X, and let's have that apostrophe right there. Let's run section. Ooh, you see that? Now we have negative numbers. So if you wanted to keep these the same, I would use this. But if you really want a complex conjugate, then I would use this. But so be wary of that. All right, so let's look through our assignment that we have right here. Oh, it's right here. So some really nice commands, and I'll let you try this on your own right here. It's not that bad. It's self-explanatory. Flip up, A, flip left, right. Really useful functions to get used to. There's a lot of functions, and MATLAB can do a lot of things. So let's see. Also, it can do some cool mathematical computations. So actually, let's do that right now. So actually, let's copy this. There we go. Copy that. There we go. And let's run that. Boom. Cool. So now we have two vectors, or matrix, or arrays, or whatever you want to call them. We have x and y. So let's do some mathematics. So there's two ways of performing a multiplication. So you can either do it like this. So let's call it A1, just an answer one, first answer. We can do x dot apostrophe y, and what this basically says is we'll multiply each element with respect to the same position. So we'll do 1 times 3, 2 times 4, 3 times 5. So let's run that right now. Oh, oops. Check for miss. Oh, I forgot. Sorry. There we go. Dot multiplication. Let me just space this out. So why didn't I use the star? So this star basically says we're gonna do matrix multiplication. So if you want to do some crazy big matrix multiplication, you can. For me, and this entirety of the class will mostly be using element multiplication. So to do elements, we do this little period and multiplication symbol, and this will do what we were talking about. That's our first error, by the way. So let's run that, and boom. 1 times 3. Oh, 1 times 3, 2 times 4, 3 times 5, and boom, elements. So you're wondering, okay, matrix multiplication, I want to have a 3 by 3 square. So if you want to do that, this one is a 1 by 3. It's a 1 by 3. If we try to multiply these together, nope, it won't work. You want to see it? It won't. Incorrect dimensions. So to make it match, so we're gonna make this. So this is 1 by 3, 1 by 3. So that means so 1x3. Now that's dumb to say. So the point is, we want to at least flip one of these. So let's flip this one right here. So now this one's gonna be a 3 by 1, and this is a 1 by 3. So now we'll have the following. Pretty cool, right? And if you want to check that for me, you can. But for the majority of this class, we'll be using our elements, our elemental thing. That can go away. So yes, we're gonna be using element multiplication. So the rest is self-explanatory. Same thing with powers. Suppose you wanted to do some variable q is equal to 2 to the power of, I don't know, 3. So this is fine because it's all scalar. But suppose you had two values. Let's say q is equal to 1, 2, okay, 2, 3, and p is equal to 2, no, 4, 5. And then let's make actually no, let's not do that. So we're gonna do q to the power of 2, and I wonder what this is gonna result in. Yeah, it's not gonna work because this one's just saying it's q times q, and this is the same case as we had here. This is a 1 by 2 times a 1 by 2, which does not work. So if you want to do elemental stuff, we have to include this. So that's the only way it's gonna work. And you're probably going crazy, like saying, "Oh my gosh, what did you just do?" So P2, what we just did was this Q dot times Q. So this right here is the same thing as this. So if you don't believe me, let's run that same answer. And to represent this, which generated an error, this is what we got. And let me just comment that. This is a 1 times 3 by 1 times 3. And by matrix multiplication, this is not going to work. We have a 3 and a 1. So if you don't believe me, run that error. Woo! Nice. See? So now you can, there's two ways of learning. You can either learn by reading the MATLAB handy manual on Google, or you can look at these errors that pop up at times. So now that we know that, we can go to the assignment. And right here, we're going to look at generating signals. So right here, I'm just looking at if you can actually type some stuff. So these ones are going to be fun, but the one thing let's go over is the unit impulse sequence. So what's the definition of the unit impulse sequence, you say? Well, in other words, we're in a discrete domain. So MATLAB is going to be in boxes. So everything is going to be in a box. So let's just treat it like that. So there's a thing called the Kronecker delta, where at n or time or whatever interval at that point, at that n equals 0, we're going to have a spike of 1. We're going to have an amplitude of 1. So we have our little time scale. Let's create our time scale. So let's call this one exercise 1. And then we're going to do our scaling. So let's do a variable n, which is equal to -5 to 5. So this right here, you're probably asking, what does this mean? So this colon symbol right here basically generates a row number. So it just generates, numbers between this point and this point. So if you don't believe me right here, let's go to the handy dandy manual. Somewhere here. Aha, you have to read further into the thing. So this basically tells us to define simple vectors. So just, easily to count. Here's your little argument right here. You don't have to put this one here because it's defaulted to 1, but suppose you wanted to count a different scale. Like suppose I wanted to do this won't work. Go to 6. Actually, yeah, I think 5's fine. Okay, we're gonna go into 2's. Let's run that. 5, 3. You see this pattern? Pretty cool, right? But point is, it's left to 1. You can either do this or you don't have to do anything. So let's run that. Now we have our simple vector. That's our interval. So what we said was the Kronecker delta. So let's call it just delta. Is going to be, so for -5 to -1, we're going to be at 0. The amplitude is going to be 0. So we're going to need 5, 4, 3, 2, 1. We're going to be 5 zeros. So let's do that right now. 0, 2, 3, 4, 5. Then we're going to spike at 1. And then from 1 to 5, we'll need another 5 zeros. 1, 2, 3. And this is all I'm looking for. So now, how do we see this? And what we ask for is you need to use the stem function. And it doesn't mention that you have to use the figure function, but you have to use the figure function. So the figure function basically just instantiates, like a canvas or like a plate or a palette to do whatever you want to instantiate graphs or plots or pie charts or anything you think about. So let's run this function. If you don't think if you think I'm crazy. So that's like, you know, our where we're gonna plot our pictures. So this basically says, okay, get ready to paint something or plot something or anything. So you always do this first, and then we put this number 1 to represent the first window. You can put this as any number 2. So, but I like to start in increments, so this is good to start with 1. We're already at the 20-minute mark, but let's try to finish this as soon as we can. So stem, this right here is going to create some stem plots. So it's going to create, like, you know, these little tick marks or sticks or whatever you like call, or stems, which is literally what it's called. And it tells you some cool things. So y is our amplitude and x is our time. So we want this. So we have to give it this. So we're going to give it this n, which contains our vector of 11 elements. You can check your size right here. Make sure they're the same size. If you don't, you'll encounter problems. And we might generate that later. That's our x-axis. That's our y-axis. And let's run it. There we go. And boom, is that a Kronecker delta? Oh yeah. Huh, this is the new, whoa. This is the new 2020 edition of MATLAB, version A. So this is the future. This is what you paid for. It's pretty cool. I've never seen these. Ooh, cool. So the point is, this right here is your Kronecker delta, but will I know it when you send it to me? Probably not. We know it, but what happens if you look into the future? Are you gonna know it? So we need to title this. Make sure you title stuff, you label stuff, or else you'll get docked. So how to do that? So there's 2 useful functions. There's the title, which is basically you can title whatever you want. Let's title it. You can either use these apostrophes or you can use these little quote marks, and we will call it the Kronecker, or actually not the Kronecker delta. Let's use the actual name, the unit impulse sequence. And if you want to see some advanced stuff right now, for those who are watching the video and think, man, this guy's boring. So there's this thing called LaTeX. We can use LaTeX into our titles. So to instantiate a LaTeX anything, we can use this little backslash right here. And then let's do delta. And then let's do this. And let's run that. Ooh, you see that? Pretty cool, right? Actually, come on, move. You can see we have a little Dirac delta right there. Pretty cool. And let's go down here. Label, no, X label. So X label and Y label are 2 functions. They literally just label the axes. So let's do this. X label is going to be n. And then Y label is going to be, call it amplitude or value, whatever you want. Run that. Boom. Pretty cool, right? And now you have a pretty picture to, you can copy figure, create a Word document, and paste. And boom. You're done. Well, we're going to be teaching you some other techniques on how to publish stuff, but this right here is just a brief introduction if you need another point of view of how to do MATLAB. So that was that. That's literally how you do the first problem. And I'll let you do this. You have the theory. And, oh wait, that's the wrong side. Point is, you have all these signals, and I'm just looking that you can explicitly list them. So suppose, let's look at number 2, and you're like, man, what does this mean? How do I do it? So I'm not gonna solve the problem. I'll show you what to do. exercise 2. Oh, oops. Let's do this. So for this one, let's create let's create two vectors. Let's call it v1 is going to be, let's go 0. Actually, let's do this. 1, 2, 1, 0. I think that's what we should do. Okay. 1, 0, 1, 2. Actually, yeah, that's good. So we have 6 elements. Let's call it v2. And let's do this 0, 1, 2, 0, 1. Actually, nope, no. 2, 1, 0, 1, 2, 1. There we go. So we have 2 vectors, and you're wondering, oh man, I wish there was an easier way of seeing this. So let's create a new time, n2 or time 2 or whatever you want. And I would like to see this for 0, 1, 2, 3, 4, 5. So let's do the following from 0 to 5. That's my time. So yours may differ, but this is just purely for example. This is not doing number 2, but this is like a roadmap to doing number 2. So let's do figure 2, and let's do stem n2 v1 figure 3 stem n2 v2, and let's call this a title v1 and x label. Haha, boom, boom. There we go. Yep, and yes, you can use copy paste. So if you love copy paste, it's the class for you. Boom, boom, boom. All right, let's run that. And look, now we have 2 signals. So, let's say, suppose I wanted to stitch these 2 together or append these 2, to make it look periodic. So, let's suppose I call big V is equal to, let's do this, v1 and v2. So, can you guess how many elements this one has? Well, if your answer, let's just show you. Run. Actually, there's another way of running. You can evaluate section by F9. I can't do that because it'll stop the recording. So, F9 and big V is 12. Woo! So, 6 elements plus 6 elements is 12. And now we're like, suppose we wanted to see the answer. So let's call figure 4 stem. So the time is different. So this is where you can create your own time, and your times may differ, but ideally let's just start with, your most bottomest term, and we're just adding something. So let's go from, well, I did start at 0 and then 5. Now we're going to add another 6 elements. So from 0 to 5 and then plus 6. So 11. Perfect. So let's call big N is equal to 0 to 11. So now we have 12 signals, 12 values. Make sure they're the same, because if not, I'll bark. But if you don't believe me, suppose you were like, 12, okay, easy. So big N, big V. Yeah, it's gonna run, right? What? X must be the same length as Y. So make sure you check your variables. Here's big N. We have 13. Oh, they're not the same. So let's change that right here and run section. Oh, look, it looks like a periodic wave. Oops. It's not like we're appending stuff. Just kidding. Oh, where did my windows go? So, they're gonna be in the background right here. But there's an easy way to let's say you have a whole bunch of graphs and you're like, oh gosh, they're everywhere. For me, I like to use close all, and that closes all your figures. So very useful function. So that was number 2. Not really, but just a tisk. And then yeah, you can solve this on your own. It's negative. Well, what does it mean? Oh, if you've studied signals and systems theory, this one just reverses everything. So not the amplitudes, the time. So I'll leave that to yourself. Flip flip somewhere here. Oops. You'll have to do some reading. And most of this stuff is all self-explanatory. And let's go to 6. So exercise 6. So now you're like saying, oh man, an exponential. How do we do this now? So an exponential with a power of j. What does that result? It's going to be a complex value. So here's the thing with MATLAB. MATLAB is real. MATLAB will tell you real things. Do you think an oscilloscope will tell you what the imaginary components are? Or do you think we can output an imaginary signal? No, because they don't exist. We can't output delays. We can't output anything that can't be generated. So MATLAB will show you only the real stuff. That's if you tell it, hey, I want to see imaginary stuff too. So suppose we were to do the following. N is equal to minus 5. Yeah, or minus 10 to 10. All right. And let's call, actually, let's do r is equal to exp. So this one is the exponential of that, or you can do something else, but let's just use that, of j dot times. I like using this dot times thing because it makes everything easy. I don't like not knowing what's going on, but this one will always do elemental multiplication. Get used to it. And then pi, which is, that's how you write pi. That's a registered value. Dot times n dot divide 10. Ooh, yay. So now let's run this. As you can see, we have imaginary and real numbers. So now you're saying, now we gotta plot stuff. So we gotta plot the real and imaginary. So let's just plot, let's do figure 5, n, and r. There we go. And you're like, yo, this is easy, man. Hey, wait. Oh, look, sine wave, cool, right? And you're like, what's this? It only plots the real parts, so remember that. And you're like, hey, well, how do I get the imaginary? So to get the imaginary, there's the imaginary function. And we can get that right here. Let's do real imag of r, because this is our variable of interest. So this one will give us the pure imaginary stuff. And actually, let's just title this complex, and then let's call this, okay, let's do this, boom, imaginary. Let's title this one RM. There you go. Oh, look, it's the imaginary component. And you're like, hey, I want to see the real component. Oh, this should be 6, by the way. RE. So to see the real components, you can either do this, but you'll get the error. But if you want to make the error go away, you can use real of R. and this will generate your thing. RE real. Boom. This is figure 5, figure 6, and yeah, these two should be the same. Figure 5, figure 7, but one of them gives you this cool error. Oh, look at that. Oh, real and imaginary, cool. But you're like, hey, I'm a magnitude guy. I like Bodhi plots. So, okay, for you guys who want to do it, our abs. It's gonna equal to abs of r. Abs is basically the absolute value. So, let's do that right now. And figure 8. Abs and absolute. Let's run that. Oh, look at that. Oh, what happened? So here's a question Dr. Stubert always asks. What is the magnitude of e to the j something? So that's a thing for you to look into the notes. Also, here's your answer. 1. Cool. So this is it for the first assignment. Hopefully everyone will get on board with this. This is just a general way of just practically just getting everything to work. So that should get you started on the first assignment. If you have any other questions or any other topics I should go over, let me know. So have a good night, y'all. And let's do a quick outro music. So take care.